All right, continuing our systems of equations review, in this video we're going to talk about the elimination method, also called linear combinations method. So in elimination method, I like calling it elimination because it sounds like what you're going to do. Our goal is to eliminate one of the variables from the system. So our first step is to arrange the equations so that the x's and y's line up. All right, so in this example over here, you see how the x's and the y's are lined up in the system. All right, if necessary, we're on to step 2. If necessary, we're going to multiply one or both of the equations by a number to get inverses for one of the variables. Now, if you notice the y's, the coefficient of the y here is 1, and here this is also 1. But this first one is a -1, the second one is a +1. These are inverses of one another. When I add -1 and +1, I will get 0, thus eliminating y. So if your equation does not already have that, then you do need to multiply one or both, and I'll do an example that does that. Okay, so in this example, 1 and 2 are already done for us. So we're ready for step 3. So now we're going to add the equations. All right, so when I add these two equations together, it's just like I'm combining like terms. So 3x plus 2x is 5x. And then -1y plus 1y is 0, like we talked about. Those ended up eliminating or canceling out. And then 15 plus -10 is 5. And we're going to solve for the remaining variable. So x is the remaining variable, so just solve for that. And we get x equals 1. All right, so now step 4, we're going to plug in our answer from step 3 into one of the original equations and solve for the other variable. So it doesn't matter which one. I'm just going to pick this one right here. So I'm going to plug in 2 times 1 plus y equals -10. So I have this equation. I'm solving for y, so I'm going to subtract the 2. And so I get y is equal to -12. So my answer to this system is 1, -12. And that's our elimination method. Let's do another one together. All right, so in this second example, you see how the x's and y's lined up, so that first step is done for us. However, you see that the x's have different coefficients and the y's have different coefficients. So we need to multiply one or both by something. My personal opinion, I see that on the x's, 4 is a factor of 8. So if I were to multiply that by 2, then I would have the exact same coefficients. So, and remember, we want them to be inverses, so I don't want it to be exactly the same. I don't want it to be +8 like this one. I want it to be -8. So I know I'm going to multiply that first equation by a -2. So if I do that, make sure you're multiplying everything in that equation by -2. So that's -8x, +6y, and then -30. So now I've multiplied, and I have inverses in front of the x. So when I add these equations together, the x's cancel out. I get 8y, and over here I get -40. So if I divide by 8, I'm going to get -5 for my y. So now I'm ready to plug that back into one of my original equations. I'm just going to pick this one right here. So I'm going to do 8x plus 2 times -5 equals -10. So I'm going to add the 10 over. That's going to give me 8x equals 0, divide by 8, so x is equal to 0. Remember I said that's okay. So then we have our final answer of 0, -5. All right, so I want you to try this second example on your own. Pause the video. I will also do it using elimination, and then you can check your work. Okay, so my answer, I got 11, -3 for my answer. Now, your work might look a little different. I chose to eliminate the x variables, so I multiplied the first equation by -2 and the second one by 5. So you can see my new equations here in red and blue. You might have chosen to to eliminate the y's. So if you did that, your top equation would have been multiplied by 5 and your bottom equation by 3 or negative 3. Okay, and that's totally okay. So your equations might be different, but your answers should come out to be the same. All right, keep in mind, the reason I chose to do this way is because my top equation was multiplied by a 2 rather than a 5, and that made that 46 easier to do in smaller numbers. Also, another comment, once I got here to y equals negative 3, I plugged that back into my original second equation, because that means that my numbers were smaller and I didn't have to work with bigger numbers. So I suggest you do that, but again, you could have plugged it into either your red or blue equations as well, and you would get the same thing. I only want to show you one more, because on all of these, step 1 was already done for us. So if we look at either of these examples, let's do the second one. All right, so you see how x and y are on the same side in that first equation, but in the second equation they're not. So we would want to rearrange this. I would add the 8x to both sides, and that would give me 8x plus 2y equal to 18. And I'm going to go ahead and rewrite that first one too, 4x plus y. And the reason I wanted to show you that, because a lot of times in our geometry problems, it's not going to be set up real nicely for elimination. So you might have to do that first step. Or some of you might choose, this one would be very easy to solve for y, and you might choose substitution instead. So I just want to point that out to you, that sometimes you have to rearrange them in order to use elimination.